So here we're going to talk about what's referred to as qualitative analysis. Now, just for some semantics, quantitative analysis is actually a junior level chemistry course where everything is very quantitative in terms of I need to know this specific amount of this substance or a certain concentration. Qualitative analysis is much more touchy-feely in terms of yes, no, this is here, this is not here, but not in terms of any sort of quantitative, oh, I have a solute dissolved, and it's this specific concentration. Qualitative analysis is basically yes or no, does this stuff exist in this particular solution? So, easiest way to think about qualitative analysis is sort of like to think of this hypothetical situation where if I have a solution that contains both dissolved silver ion and copper ion in solutions at the same time, and I want to separate the two species in two containers, what do I have to do? So if I have dissolved silver ion and dissolved copper ion, I can add any number of anions. So for example, I could add carbonate, and the carbonate ion, using, for example, sodium carbonate, which dissociates into sodium ion and carbonate ion. And the carbonate would precipitate both the silver and the copper and get rid of them out of the solution. But if I wouldn't be separating those two species. So what I need to do is I'd have to add an ion that selectively precipitates one of those and not the other. And because of the solubility rules, it will be easier to precipitate out the silver first. So, for example, we could, if we wanted to separate silver from copper, we could add sodium chloride to the solution. Sodium chloride dissociates into sodium ion and chloride ion. The chloride ion would then precipitate with the silver. Makes it precipitate, falls to the bottom of our container, we filter it off. Then we could add some other anion. So, for example, we could add this sodium carbonate, which then would precipitate out our copper ion, but we wouldn't have to worry about it also precipitating out the silver because we've already removed it. So this process where is for determining the identities of the ions in solutions called qualitative analysis, or just a qual scheme sometimes is another way it's referred to. So it's the successive addition of aqueous ions, anions to precipitate cations in a very particular order, and we use them to determine the identities of substances in there. So this is what's referred to as a qualitative analysis scheme. So we take all the large number of metal cations and we put them in terms of groups based on their chemical reactivity. And there are 5 groups, oddly named groups 1 through 5. And the idea of qualitative analysis is that we sort of step through these reactions in a very specific order. So let's go through it, and it'll probably make a little bit more sense if we just kind of go through it as an example. So I have a solution that contains any number of ions, and I don't know what ions are in there. So first thing I want to do is I want to add hydrochloric acid, right? So just some acid that also contains chloride ion. And if I get a precipitate, that means if these are the possible cations in my solution, then if I get a precipitate, it's one of these 3 because silver chloride, lead chloride, and mercury chloride are insoluble in acidic solutions. So if I add to my unknown solution, and I add HCl and I get a precipitate, I can beyond a reasonable doubt, conclude that at least one of those group 1 ions in there. Now, from this analysis, I don't know if that precipitate that I see, is it silver chloride, is it lead chloride, or is it mercury chloride, or it could be 2, or it could be all 3. That I don't know. If I get a precipitate, all I can conclude is that I have at least one of those. Also, I can conclude if I add my HCl and I get no precipitate, then that means I can conclusively say that I don't have any of those. So whether I get a precipitate or I don't get a precipitate, if I do get a precipitate, I kind of filter it off, just run through some filter paper, and then I take my remaining solution, and we still have groups 2 through 5, determining whether or not we have those in our solution. So the next thing to do is add some hydrogen sulfide or some other sulfide. It really doesn't matter. It could be sodium sulfide. Still keep it acidic. And if we get a precipitate, then it means it's one of these group 2 cations. Because the group 2 cations, so all of these ions are the same ones as sort of like listed here in green, so we call them the group 2 anions. So if we get a sulfide, if we get a precipitate after adding hydrogen sulfide, that means one or more of these ions are present. So copper, or bismuth, cadmium, at least one of those exists in our original solution. Could there be two? Yes. Could there be four? Yes. We have no idea. All we can say is, if we get a precipitate after this step, is that at least one of those is in our solution. We get a precipitate, we don't get a precipitate. If we don't get a precipitate, we know that we have none of those. If we get a precipitate, we filter it off, and then that solution that runs through, we still have the remaining cations that could be groups 3, 4, or 5. So we need to separate those. So the next step is our step 3. So in this case, all we're doing is we're keeping the sulfide ion in that solution, and in here, in this example, we used ammonium sulfide, but it really doesn't matter what sulfide we use. The key here is that we are making the solution basic, because the group 3 species are sulfides and also hydroxides that are insoluble. So the basic sulfides. So cobalt sulfide, as you see here, cobalt sulfide is soluble in an acidic solution. Doesn't precipitate over here, but if it's in a basic solution, which we've made here, then cobalt sulfide is actually insoluble and it forms a solid. So just like the previous steps, if we add our ammonium sulfide, we make our solution basic, and we get a precipitate, we know conclusively that we have at least one of these group 3 cations in our original solution. We could have 2, we could have 3, we could have 4, we could have all of them, we don't know. But we can conclude that we have at least one of them in this solution. Next, if we don't get a precipitate, we can conclude that we don't have any of those group 3 species. So if we get a precipitate, we filter it off, and we still have our remaining cations. And now we add this hydrogen phosphate. It's hydrogen phosphate species, which is really just a source of phosphate. Here it's ammonium hydrogen phosphate, but all we really care about is adding a phosphate. Could be a bunch of other things. And it's still basic. And if we get a precipitate after adding the phosphate, then we know we have at least one of the 3 group 4 species, right? So barium and calcium and magnesium. So there they are, barium, calcium, magnesium. Those are our group 4 species. And if we get a precipitate at this step, we know we have at least one of these. If we don't get a precipitate, we can conclude that we absolutely do not have any of those. And then lastly, we have the last of our qual scheme is sodium and potassium and ammonium ion. We could also lump in lithium if you wanted. And these are the group 5, which are the remaining cations, which are the alkali metals, ammonium ion, sodium ion, and potassium ion. So these are all species. We can't do a precipitation to determine their identity because ammonium ion salts and sodium ion salts and potassium ion salts, they're all soluble. So there's nothing that we can add. We can't come up with a cation or an anion to add to this solution that would precipitate those out. So sadly, using this analysis, this qual scheme, if you will, only identifies the presence of group 1s through 4, because group 5 kind of can always be there because we can never get any sort of visual evidence in terms of a precipitate that these ions were actually in this solution. So let's go through just one quick example. So a solution containing an unknown number of metal ions is treated with hydrochloric acid, so no precipitate forms. So we go back to our first step. So this is just our first step. We added HCl, and no precipitate has formed. So that means, conclusively, that we don't have any silver or lead or mercury in this solution. We adjust the pH to about 1, so it's acidic. And then we had hydrogen sulfide, and again, no precipitate forms. So that's our second step. We're still acidic. We had hydrogen sulfide, and we said that there was no precipitate, so we can conclude that we do not have any of these ions in that particular solution. That's our conclusion we can make so far. And then, again, no precipitate. Okay, then the pH of the solution is then adjusted to about H. More hydrogen sulfide is bubbled through. This time a precipitate forms. So we go back to our qual scheme. So here we are here. We added ammonium sulfate, made it basic, and we got a precipitate. So we can conclude that at least one of these 8 species is in our solution, in our original solution. Could be 2 of them, could be 3 of them, could be all of them, but at least 1 is in there. So for precipitate, the filtrate from the solution is treated with the ammonium hydrogen phosphate and no precipitate forms. So that was our last step for checking for group 4, and since we got no precipitate, we can conclude that we have none of these cations in our solution. And then now the question is simply asking which metal elements are testable in a standard qual scheme possibly present and which are definitely absent. So we knew that there were no group 1s, there were no group 2s because we didn't get a precipitate here or here. We have at least one of these, so these all fall into the maybe category. We didn't get a precipitate at this step, so these are all a no, so none of those ions are in there. And of course, in group 5, we can always have one of those. So at this point, we have to put those ions, and we just have to put them in the maybe pile, because we don't have any evidence one way or the other of their existence in our original solution.